So we're going to look at expected value with hypergeometric relationships. So they've given us our question here. The first thing we actually want to look at is how to calculate expected value in a hypergeometric relationship. And they've given us three variables, an R, an A, and an N. So we're going to try to define them here first before we kind of get into what this question's asking us. So our R variable is the total number of trials or samples. So essentially when we're trying something out, how many times did we go about doing it? How many times do I randomly draw people from a population? In contrast to that would be the total number of a population. That would be like, so we can try to, let me highlight this, N, and our N is the total number of a population. I'll try to draw the difference between these two ideas. I think of it as the country of Canada. Our population is like, I think, 33 million, 38 million, somewhere around there. You wouldn't take 35 million samples. That's far too many. So if we were trying to take a survey of Canadians, maybe we survey 100 Canadians in total. Okay, so that means we took 100 samples, but the total population is like 35 million. So that would be the difference between R and N. N is the total number of the population, and R is the total number of samples that we take in our trial. Okay, and then A is the number of successes in a population. So that's kind of like the probability in a population. So maybe we're testing for for left-handed people, and it's like got a 10% rate of left-handed people. What is the number of successes in that population? How many successes do we expect to have if 10% of Canadians are left-handed? Well, if there's 35 million, take 10% of that. I think we're looking at like 3.5 million people. That's 10% of 35 million. I know I did it in my head, but that would be kind of the number of successes. And then what are the expected number of successes, or our expected outcome in here? Okay, so we tried defining these. Let's see if we can kind of pinpoint the information in our question. There are 300 tagged bears. Let's see if I can fix that. These are kind of broken sentences. We caught 25 bears and found 10 to be tagged. What is the population of bears? Okay, so we caught is talking about our sample. Okay, so how many samples did we take? Well, our total number of samples, we took 25 bears. So that's essentially going to be, oh no, wrong color. That's going to be our R variable. Okay, there are 25 bears in our total sample. So we have that right now. So we'll say R is equal to 25. We know that there are 300 total tagged in the population. Okay, there are 300 tagged bears in the total population. So when they're talking about, think about how many bears were successfully tagged in an entire population. Well, that's when we're talking about the number of successes in a population. Okay, so because there are a total of 300 successfully tagged bears in the entire bear population, that means our 300 is going to be our A variable here. Okay, so we'll highlight it in green. So 300 is our A. A is equal to 300. Now this is the tricky part here. Our expected outcome. Well, our expected outcome in this case is actually the 10 bears that turned out to be tagged. So an expected outcome is the expected number of successes from your trials. Okay, well, we already know we took 25 bears and we successfully found 10 to be tagged. So I know I didn't give it a color. Let's give it like a purplish color here, but that's our expected outcome. We found 10 of the bears to be tagged. That was our expected outcome from our 25 trials. We didn't have to calculate it, it was already given to us. So the unknown right now, and essentially what they're asking, is what is the population of bears? Well, remember, N is always the total number in a population, the total number of the population. So N is our unknown. So we're going to go about filling these in here. We have 10 is our expected value. R was our 25. Our A value was the 300 bears that we know to be tagged. And then our total population is, we'll leave it as n. N is our unknown here, okay? So we just kind of got to remember algebra rules. The key here is we need to isolate for this n variable. I'm going to write everything in black from here on in. Okay, so I'm just going to simplify here. This is like multiplying fractions. We do the top by the top and the bottom by the bottom. You can turn 25 into a fraction by just putting it over 1. So we would do 25 times 300. I think that's going to give us 7,500 over n is equal to 10. Okay, and now I want to isolate for n. Well, n's on the bottom of my fraction. So because this is division over here, to bring it to the other side, I need to multiply. So this will now read 10n is equal to 7,500. And then to isolate for our n, we just need to divide both sides by the number 10. That will essentially eliminate or create a 1 on the left side. So we're left with just n is equal to 750. So our total population of bears should be 750 out of the total of 300 that we found tagged and the 10 that we found in our samples to be